Welcome to the Software People Stories. I'm Shiv.
I'm Chitra,
And I'm Gayatri.
We bring you interesting, untold stories of people.
associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked.
and sometimes what didn't,
You will also hear very personal experiences.
and insights that would trigger your thoughts.
And inspire you to do even greater things.
We welcome our first millennial guest to the Software People Stories. Shravan is a fourth-year PhD student in the field of computer security and programming languages at the University of California, San Diego. He's in conversation with Sivaguru, talking about how easy it is to shoot yourself in the foot when developing software. His first learnings while working on personal projects from his high school days. And should every developer know everything about security? He also talks about managing and securing software supply chains and proofwriting code, while provoking thoughts around safeguarding software and the impact of computing on the environment. He shares tips on what can be done and then asks if it ultimately all comes down to cost. The discussion then navigates to the never-ending cycle of bandwidth and consumption, human behavior influencing matters of security, to Shravan's understanding of AI, and when can it actually start truly predicting. He talks about offensive security or a tech versus tech scenario, and can AI be fooled? And then finally, developing the attitude to constantly learn new things and keep up to date if you choose to pursue an IT career. Listen on.
Hi, Shravan. Welcome to this episode of the Software People Stories. I'm very happy to have you as the first millennial guest on the show.
Hi, I'm thrilled to join. I'm glad to be here.
And as we normally do, we let the guest do a self-introduction so that we get the background directly from your own words.
I'm Shravan. I'm currently a PhD student at the University of California, San Diego, doing my PhD in computer security. Before this, I was in the software industry working at Microsoft for 3 years. So my background is at this point a mix between the software industry and academia. Currently, my research is on building secure sandboxes to run software safely. The primary idea behind this is if we want to use someone else's code, can we use their code without safely in a way that doesn't include all the vulnerabilities they may have accidentally included in their code? So I'm doing a bunch of work around this.
Okay, I'll come to that in a bit. What you said triggered a few questions in my mind. But first, what got you interested in software?
I think it might have been a comic book, actually. The Dilbert comic, there was one random Dilbert comic that just showed how an office coworker played a prank where they got another person's computer to beep every 20 seconds or something. And it seemed like a fun little harmless prank, but that's what actually got me into it, as silly as that is.
Oh, wow. Yeah, I've heard people getting into software because they love playing games. And
Games were also actually an interest. That's very shortly after that, I did spend a lot of time developing games as well, and I can talk about that if you're interested as well.
Yeah, definitely. What do you find most satisfying in terms of writing software?
Oh, it's a puzzle. I think it kind of appeals to the same, I think, part of the brain that likes puzzle solving. So I at least personally, I've seen a lot of overlap between people who like to do things like software debugging and people who like solving simple like puzzles like Sudoku or Kokoro or things like that. And it becomes this constraint solving puzzle game that you can incrementally make progress on. And that's the part that actually feels like fun. And at the same time, it also gives you a little bit of like, it's a mystery. When a piece of software fails, as it inevitably does, you always have to follow it up and figure out exactly what happened. And that involves almost in a detective-like fashion, putting the pieces back together and trying to figure out exactly what happened, what went wrong, and what do you need. And again, I think that comes back to puzzle solving.
Was that also the reason why you wanted to pick computer security, where you probably have to go into the minds of people who probably haven't been expressed as software as yet, who could probably penetrate and cause damage?
I would say my interest in security actually stemmed from a slightly different angle, which was more from the sense of as I was writing more and more software, every now and again I would catch myself making essentially a security blunder. And I was wondering exactly why it's so easy to shoot yourself in the foot when writing software. And that's actually what drove my interest. Because especially when you're writing systems programs, things for operating systems, things for games, which have to be fast, you're using tools and languages which don't necessarily protect you from yourself. And they don't, because normally these things come at a cost of, and you need to have efficient tools and languages so that you can write high performance operating systems. But the cost is you are more likely to make security mistakes. So that was sort of the question that led me into the security area. And even with higher level languages, it is still remarkably simple to make a mistake which could compromise the entirety of your application. For example, just by forgetting to authenticate a request at any point and so on. So I think it came from a first-hand experience of trying to write software and realizing that you can make security mistakes at any moment.
If it is not confidential, can you share what was the impact of missing something?
I think many of these, so I actually started programming seriously in the 9th grade or something. And so a lot of the initial ones actually just came from personal projects. But these are things I put out on web servers, whether it was like a small website that translated random video feeds to RSS style feeds, etc. But seeing that it's a public website, anyone can take that down if there is a vulnerability. And so many of these stem from personal projects. Thankfully, at the times that I've worked at the companies, there have been enough code reviews and people looking at it that we usually try to have found these ahead of time.
Working in these kinds of areas, when you mentioned operating systems or security and compliance and those kinds of challenges, the core logic, or let's say the data structures and algorithms, have not evolved too much on the traditional application space. Whereas in this space, with every challenge, probably there are new models that are coming up. So as a developer or as a researcher, how do you find out what are all the possible gaps that need to be plugged and prioritize on picking up area to work on?
Okay. And when you say gaps, you mean the security gaps then?
Yeah.
Okay. So that's a fantastic question. So I think it boils down to this, which is how much cognitive burden can you reasonably put on a day-to-day developer when literally the only part of the job description is to actually finish the application. Security is implicit, but is not actually present in the statement of their job. So at that point, you certainly can't ask them to know everything about, these are all of the million ways a piece of software can be compromised, attacked, and so on. So I think this is actually a place where a lot of research is happening, and a lot of research needs to continue to happen, where we essentially need to reduce the number of things that average developers need to know. You could make an argument, well, every developer should know everything about security, but I don't think that's sustainable. Because even as you pointed out right now, there is a ton of new stuff coming up. Even just in the last 2 years, we've seen a host of vulnerabilities at the hardware level, which can compromise your software. And these are referred to as Spectre and Meltdown, if any of your listeners are familiar. But if you have looked at just the set of security news coming out in the last 5 years, we found that people have managed to attack any application at various levels of the stack, including from the hardware itself, meaning the processor, from the supply chain, meaning the delivery of the software to the end user, whether that comes from the hosting server, the CDN, the DNS, the checksum manipulation, etc. And then not to mention the actual software vulnerabilities, which also come at a host of levels: low-level memory security vulnerabilities, application vulnerabilities in third-party code, and so on. So the number of avenues in which things can go wrong are increasing. So I think what is needed is more research into like coarse-grained solutions, things that we can say, well, we've deployed this, and now we know that these set of areas are not an issue.
Yeah, interesting you use the term supply chain, because when one looks at a supply chain in the physical world, we talk about also the logistics of moving things around, where the public infrastructure in terms of roads or railroads, whatever, are more known and documented. Whereas on the net, I suppose it's very difficult to predict which path it will take, or how you can reasonably create maybe guardrails, for the connection to be secure, right?
Yeah, I think it's a fair point. I mean, that's not stopped people from trying. I certainly know of a couple of research projects out there who've tried to do this. And what they've done is essentially tried to model what the entire development chain looks like. So they've said something to the extent of, well, developers start by writing code on their own computers, and then they submit it to some central code repo. And then there is a build server that retrieves the code from here and builds it. Then there's a testing server that takes the software, moves it onto that machine, runs tests. There's a packaging server that takes all those binaries, puts them into a software package. Then you ship them to the operating system storage. Operating system package manager storage, and so on. So there is a long, elaborate chain of the code going from place to place. And while it is complicated complicated. It's not the same as saying we don't know all of it. We do. It's just extremely complicated to track, which also makes it hard to secure, but it's not stop people from trying. It's these sort of efforts are still pretty nascent, but they're out.
So this seems to be adding more and more layers of complexity. So how much impact does this have in terms of the compute power that we need, or the computing complexity?
Right. It's a good question. Certainly, security is not free. And I think that's probably the first thing that any security professional will tell you. And it really depends. There are, for example, let me give you another example, which might complicate this question a little more, but I think it's an interesting discussion to have, which is there is a separate area of research called verified programming, with the idea being you can write a piece of software and prove mathematically that software will do what it claims on the tin. So it is mathematically impossible for that software to fail with a bug or with an out of bounds exception or what have. And so this, for example, requires a lot of additional effort on the developer side, because not only do you have to write the code, you also have to write the proofs that does the right thing. And there's been various surveys to look at this, and it's right now a very niche sort of skill. You'll mostly find it only in very, very high value environments, maybe like NASA or in academia, for example, where they're still trying to figure out ways to make it easy. But on average, what they found is if it takes 1 day to write a piece of code for a software, it takes about 5 days to prove it right. So it definitely, there are various cases where this cost of security is high. But to offer like a contradictory point on the spectrum there, one of the things which I mentioned earlier, which is software sandboxing, is now sort of coming to its own in the last couple of years or so. And to a point where there have also been a lot of efforts in reducing the overhead. So the key with software sandboxing is that you want to use the same code that you had before, but hopefully with a few more security guarantees. And through a variety of hardware and software changes, people are trying to achieve this. But this, of course, slows the code down a little bit. But with the latest efforts, the code is now, that code slowdown has reduced to like under 10%. So there is clearly a spectrum of like, what is the overhead, what are we willing to accept, and so on.
The complex algorithms, at least all these doomsayers say, is that it increases global warming.
Oh, I think Bitcoin is probably a better thing to point to for that.
Yeah.
I think, I wouldn't trust me on this particular statistic, but there is some statistic out there that Bitcoin mining takes as much electricity right now in the world as used by like multiple small countries or something like that. It's a pretty significant part of energy consumption. Right. All for determining, all just to mine more Bitcoin, which is essentially a process of constructing hashes, which is explicitly designed to be a computationally heavy thing without too much of a benefit. And it's designed to be heavy so that mining is not an easy process, so that there is value to doing that task.
Is there anything being done to consider that in terms of more maybe responsible computing?
So responsible, not to my knowledge at least. I mean, I could be wrong, but there has always been an effort for low energy computing, which is also coming back to the forefront because of the Internet of Things. And the Internet of Things are basically a set of devices they don't have an online power source, so they have a battery typically, but they are connected to the internet, and they are typically sensors or small appliances which do a particular task, but also are able to respond to requests over the network or send data back to a server, etc. And the key thing about this is these are devices with very limited power sources as well as spotty internet connections. And all of these actually has prompted a good amount of research on how we do things like intermittent computing. What happens if the power dies halfway, or what happens if the internet connection dies halfway, or how do you use the power that you have efficiently? So, for example, another piece of research I've seen is on Android phones. Researchers tested what happens where if you, instead of sending all the data out from all the apps at the same time, if you batch them into little packets, and they found fantastic power savings, over like 30, 40, 50% of the power, etc., could be saved. So there is definitely a lot of research when it comes to this. And again, the question with all of these things is, what is the cost? And if this means your web page is going to load a little slower, are people going to be okay with that? Maybe YouTube buffers a little bit before it plays the video. Are people going to be okay with that? So these are the sort of questions people have to ask after designing the initial piece of tooling that actually saves energy.
Yeah, the reason I asked that is also now there is a lot of talk about 5G.
Right.
When your channels become much faster, the expectation would also be, instant responses.
Yeah, certainly. And I think there's a probably, again, we're going, this is, sorry, I'm taking us on like multiple tangents here, but I will go for it anyway. Instant responses, there are probably two ways to interpret that. One is the bandwidth speed and one is the latency. And I think the interesting bit about 5G, which the bandwidth is great and bandwidth is certainly great, but the latency is also quite an interesting bit. And I think they've worked pretty hard to get the latency low. And keeping the latency low is what really matters for a quick response. And honestly, even for web pages, latency often becomes the bigger bottleneck than bandwidth, up to a certain point. Because you think as consumers, when we use a web browser, our indication of whether a web page is loaded is when we start seeing things happen, not necessarily when the final loading bar finishes altogether. Because we many times clicked already on the web page before the loading bar is finished because the relevant portion of the data is loaded. And that is more a function of latency. And so I think the interesting bit about 5G is certainly the latency aspect. But to your point, given that there is more bandwidth, people always seem to find ways to use it. So there's been miscellaneous statements through the years. Oh, you will never need more than X MB of RAM, or you'll never need more than so many GB of storage or so many MB of storage and so on. But every time that happens, we find more uses, more data, more interesting applications that actually are able to use all of this. And so undoubtedly, it's going to be true that even with 5G, we will find ways to use all of that bandwidth and latency. Maybe it would be something like 3D voice video calls and so on.
Yeah, because recently I came across this reference called the eroom's law. Have you heard of that?
No, I haven't heard of this.
That's basically Moore's law, Moore spelled backwards. So whatever was predicted as the hardware capacity multiplying or increasing, the eroom talks about the algorithms also getting more and more complex.
Interesting. Okay. So I certainly haven't given that much thought, because to my head, the algorithms at the low level typically would not get that much more complex, because efficiency turns out simplicity works pretty well. But I think for higher level applications, this is certainly the case. So for example, if you're talking about an algorithm for sorting or search, there is usually a limit to just how complex that those things can get. But if you're talking about applications like AI, where a lot of the research is to find the more interesting techniques to have a better prediction rate, certainly like AI algorithms have gotten much, much more complex over the years.
That's true. This comes more from that side, the analytics and AI, and more in terms of drug discovery. They say that it's getting more and more complex nowadays. So the cycle times and things that they want are much longer than what it used to be.
Right. And I mean, there are certainly a lot of exciting opportunities even there. Like in particular, your mention of like algorithms for drug testing, etc., prompted a thought in my head, which is a random fact, which I found quite interesting. Which is, have you heard of quantum computing?
Yeah.
Yeah. So, I mean, I guess just the one-line description anyway is quantum computing is computers that are designed to use quantum effects to really perform highly efficient and fast computation. You can't use the speedups to perform arbitrary computation, but certainly several applications have been sped up significantly. And one of the interesting bits is there is a common understanding out there that quantum computing can break all of our current encryption, which would mean that all of our bank transactions, all of the security we have, all of our logins to websites could all be broken. But a couple of orders of magnitude of computation before that, if we get quantum computation even 2 orders of magnitude less than that capacity, we would be able to efficiently do testing for drugs, because all of these chemicals for drugs are computational simulation, and those simulations take 2 orders of magnitude less computation than it would take to break our current encryption with quantum algorithms. So a lot of interesting things are possible with like some of the work that's out there, and quantum computation too also is like one of those areas.
A little segue. When you talk about security, and initially you also spoke about the challenges of solving puzzles, etc. How much of, let's say, feels like psychology or human behavior matter when it comes to matters of security?
Right. So the security research community does have a lot of subfields, even though I've been talking about it kind of as one thing. And certainly there are a lot of places where both technical security and more human-facing security are really different things and need to be treated differently. And I'll give you one simple example, which is the browser. It's certainly the case that browser vendors do both sides of the security and take them very seriously. And in fact, even if you look at the papers published by the Google team, you would see that they have a lot of user-facing security as well, where they've done a lot of research for things like which warning screen works best to tell a user that this site may be unsafe. And they do things like run experiments and measure the number of times users ignore the warning or versus the number of times users heed the warning when the warning is red or when the warning is yellow and so on. So there is certainly a more human side to security analysis as well. A similar thing can also be said about training programs. Every company has this mandatory training course. Don't click on email links that you don't trust, and don't ever download files from email until and so on, or don't respond to requests for money over email, etc. But even those training programs have a very similar problem, which is you could tell people all the information they would need, but unless it's set up in a way for human beings to actually process and deal with it, you're not going to actually get a lot of people to do the right thing. And so there have been a separate set of studies on how you even do those sort of programs right.
Yeah, on that track, nowadays you see a lot of applications of AI in terms of guessing the intention of the user. Like even as you type something in the search box, Google tries to anticipate and then fill up the rest of the query.
Right.
So when do you think AI would be able to second guess whatever is likely to happen and thereby actually reducing the need for a detailed study of the human behavior or psychology, indirectly kind of nudging people towards certain actions?
Yeah, so that's a very interesting and difficult question. So let me see if I can kind of break that down into 2 or 3 pieces. So there is now, because of the popularity of AI, a tendency to think that all forms of prediction are AI. But I would argue that things like Google's predictive search are not necessarily AI. The term, at least I use the term AI when we've applied a prediction algorithm which we don't fully understand because the model is so complicated and is based on an automated form of learning. However, the predictive text on things like Google, although they may use a mix of AI, are a broadly well-known algorithm, which is if you see that there is a lot of people in this region searching for, pictures of cats. And so if you start seeing the phrase PICTURL as someone's typing it out, the auto completion for things like that is pretty well known. Everyone knows what needs to happen there. So in those sort of cases, it's more standard prediction with well-known algorithms. But certainly for things like image recognition, it's not that we know very good ways to say, oh, I'm looking at a picture of a cat versus this is a picture of a chair. Mm-hmm. So those are more what I would call AI, where you send 1 million pictures of a cat and 1 million pictures of a chair to a computer and ask the computer to just read every pixel and come up with any model that it can that starts to differentiate these things. And so with that definition of AI aside, I think I'm just trying to track the second part of the question. Second part of the question is, right, when can AI actually start predicting things even before humans would realize it, maybe even nudging them to the right? And I would argue in places that's happening already. Certainly, there have been a couple of examples where Facebook has run experiments on their feed. And I think they've stopped doing this now because there was a bit of a backlash when people found out. But for example, some of the claims going around were they could tell that someone is pregnant based on the sort of post they did even before they knew, and so on. So some of these to be taken with a little bit of salt, but certainly it's probably not that far from what is possible. So I would argue in places we're already there. It turns out humans do operate a lot in patterns. And when you have billions of people to train, you can figure out the patterns pretty well.
The other side of this whole thing, on one side, when you say nudging, manipulation, and all that, at least among the youth today, we find a lot of awareness and sensitivity to, say, world peace, environment, etc. How much of this technology is being used, or is there any work happening towards helping the so-called activists?
I mean, I do know, I'm not fully up to date on that, but I do know of a couple of efforts. I do know that there's one thing called the Humanitarian Toolbox, where software, it's a free and open source set of software where developers contribute their time and coding efforts to write applications for people who participate in like first response or disaster recovery or things like that. Just even to coordinate things like we found people here, or these are the diseases that are spreading here, and so on. So I do know that there are some efforts like that. But on that theme, I think broadly, which something that people in the tech industry realize more than others, is that software is really everywhere. So a few months back, as part of a conference, we got to talking with one of the fire marshals in one of these in California. And they were explaining how they were investigating technology as a way to reduce the amount of resources needed to deal with fires. And fires are a really big thing in California. It happens often and causes a lot of damage. So they are really invested in ways to reduce the impact of these things. And so they've been using a lot of software and technology to kind of do this. And for example, I think they've looked at IoT devices that they've just put on the wilderness, which can do things like sense heat. And then they have a simple application. They know the pattern they're looking for, which just says, oh, if you see a pattern where there is a drop in humidity followed by a rise in humidity and then a rise in heat, that means that there's a fire happening. And we need to cut that off before it reaches the populated areas. And they've taken these tiny devices and they're trying to put them out everywhere. Or things like, well, if we can have control over the water sprinklers over all the edge of the city, then as the fire approaches, at that time, we will launch all of the water sprinklers at the border houses so that the fire doesn't spread further in. So it is already the case that software and technology is kind of showing up in all these places.
Yeah, these are applications of technology. What I had in mind was more of a provoking question, saying that is technology being developed to combat technology? When there are manipulative technologies being developed, is there technology that can fight such manipulation?
Oh, I see. I think there's always going to be that cat and mouse game. And I think there have been various forms of cat and mouse games. I think if the simplest example or the simplest demonstration of that with respect to this question is antivirus, right? So viruses are pieces of software that are going to harm your computer. And so people came up with antiviruses, which tries to spot them and eliminate them from your computer. And so the viruses try to outwit the antiviruses and they try to evolve. People write slightly different viruses, which the antiviruses might not pick up. Antivirus vendors are now aware of that and they try to update it and so on. And this sort of cat and mouse game happens in a bunch of places. And since we were talking about AI, a very common thing that happens right now is there's a bunch of research into how you can fool AI. So for example, self-driving cars, they operate by listening, by capturing a bunch of data via sensors on what's happening in the road, both via image, as well as some form of depth perception as well. But there's been a variety of work that shows, oh, look, I can put this image. It looks like just like this random advertisement, but the car is going to treat it like a stop sign and just stop and have every other car behind you jam into it. And so now there's been work, the AI community, to make AI algorithms that are potentially robust to these. So again, you're going to see this exact same cat and mouse game happen all over again. And finally, I think the third example I would give you here is security. There is always going to be work on offensive security, which is to say breaking into computers. And certainly the various intelligence agencies of all countries are going to continue doing this because they see this as part of their strategic incentive, part of their requirements. But at the same time, they also need to defend against potential attacks from foreign nations so that they themselves are protected. And so this, again, is one of these cat and mouse games where technology is sort of pitted against each other. So you have attacks versus defensive techniques.
Interesting. I think we can go on and on. There are a lot of these topics, a lot of these unknown areas and exciting things that are happening. But in the interest of time, I would like to ask you just one more question, which is a variant of what I normally have been asking many others who've been in the industry about careers. So in the area of academics, if someone is considering getting into, say, IT as a broad area of research or anything that is more specific, like in your case, security, do you think there is still a future?
So my view on it is a little, I guess, probably more from a safe kind of view, which is there may or may not be a future. But what seems to be the case is it's going to have a future for the next, let's say, decade. But if you get on the train, on the IT train now, if it happens 10 years down the line that the number, like there's some sort of bubble bust of some kind, and the number of jobs in IT and technology reduce, you are well set to move to the next field. Things you need to start. My view is that you need to start in somewhere, say, like the reason I'm happy where I am right now is also, say 10 years down the line, technology is fading or whatever. The number of jobs in technology is fading. Since I already have a potentially good job in technology, I'm now ready to start training on whatever the new thing is so that I can make the switch when the time comes.
That is not only reassuring, but also I guess this is a tip for anyone to be constantly reskilling or be current and have the flexibility to switch and learn.
Right. I think that's certainly my view, which is if you're well set to switch and learn, which means you have stability in the current thing, then that's probably the best place you can be.
Thanks a lot, Shravan.
Yeah, it was an interesting discussion. Thanks for having me on.
Thank you.
We thank Siddharth for the music and Malavika for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client
And spread the word in your network.
if you'd like to share your story,
contact us at podcasts@pm-powerconsulting.com.